One of the core parts of any programming language is learning how to control the evaluation of code, and R is no different. In this video, we'll turn to this topic, but to get started, we'll begin with a built-in function called message intended to message the user in a way that's a bit nicer than print. So to see what the competition is, we can type print hello world. And we see that the print on the left-hand side is black, and it has that 1 next to it. What's actually happening here is that it's printing out the character vector hello world. It's a character vector of length 1. So this is actually identical to typing hello world. There's absolutely no difference between the two. Now, the message function is in fact different. If you type in hello world, it will actually message in a different format. You can see there that it's orange, and that it doesn't have that 1 next to it. This is the standard way that R developers message users. Now, the message function is actually a little bit more flexible than this. I can store a variable x is 1, and I can say message x equals x, and it will actually message x equals 1. It will input the value of that x into that statement. So that's the message function. It's very common to want to only evaluate a chunk of code if some condition is met. For example, suppose you're writing a simple little program that messages the user, you passed, if the value of a variable named grade is at or above 60. To do this, we use an if statement like this. If grade is greater than or equal to 60, message you passed. Now, we should probably create grade first, so grade is, let's say, 50. If grade is 50, then the condition grade is greater than or equal to 60 is not met. So if we run line 2, nothing happens. There's no message to the user. However, if grade is 90, and we evaluate the same line of code again, now the condition grade is greater than or equal to 60 is true, and the system messages you passed. Note here that that part, the grade is greater than or equal to 60 part, needs to evaluate to either true or false, a single true or false. This is usually referred to as the predicate or the condition of the if statement. Now, this is the most basic version of an if statement in R, and it's referred to as an inline if statement because the entire thing is literally on one line. But typically what you want to do is more than one simple statement. It's a series of statements. That's what we're calling a code chunk or a block of code. To create a block of code in the R language, you use curly braces. For example, you can merge the following two messages into one using the curly braces. Message, you passed. Message, good job. Now, if I go up to line 4 and I evaluate this, both of those lines evaluate because the entire statement starts on line 4 but doesn't end until line 7. Notice also that within code chunks, we always use indentation. Indentations are usually 2 spaces, 4 spaces, or a tab. So the way that you usually see an if statement is like this. If grade is greater than or equal to 60, we'll come copy this like this. If grade is greater than or equal to 60, message you passed. Great job. Now, if statements are often paired with another keyword, else, they'll run code if the condition evaluates to false. So let's go back to the grade example. If grade is 90, and if the statement is if grade is greater than or equal to 60, message you passed, good job, that will function just fine. But if grade is 40, it will of course not function just fine. In this case, you may want to message the user with something else, like, oh, bummer. To do that, we'll say if grade is greater than or equal to 60, message this code chunk. But if that condition is not met, meaning if this predicate condition, grade is greater than or equal to 60, is not met, there's another code chunk that's going to be evaluated in that circumstance, and that is the message, oh, bummer. So if I run this, that's precisely what happens. It messages, oh, bummer. These kinds of statements are generically referred to as if-else statements. Note that you can also chain them together. So for example, I can say if grade is greater than or equal to 60, message, you passed, good job. And then I can say else if grade equals 60, message, whew, just barely. And else message, oh, bummer. This is an example of chaining if-else statements together. In addition to conditional code evaluation, a common task in any language is iteration, that is, the repetitive evaluation of a single chunk of code. The most basic way to do this in R is with the keyword repeat. For example, repeat message runef 1. Now this is a very dangerous line of code to run because there's nothing that's actually going to stop the evaluation. I'll start the evaluation, but I will warn you, do not run it because stopping it is actually very difficult. By the way, terminating evaluation in R is done with the escape button. Another way that we could use this repeat statement would look like this. Repeat, now code chunk, x is runif 1, so generate a number between 0 and 1, message x. Now this is going to be just as bad as the previous one, so of course I won't run it. Instead, I'm going to add a condition. If x is greater than 0.9, break. Okay, break is a key word that will break you out of a kind of endless repeating cycle. Okay, so in this case, I can run this code chunk starting with line 3, and what will happen is that R will start generating numbers randomly between 0 and 1. It will then message the number, and if the number is bigger than 0.9, it'll break. If it's not, it'll continue to repeat through that chunk of code over and over and over again. So the more times we run this code, we'll see that the number of times it will actually evaluate is different every time. For example, this time, I only needed to run it once, and the very first number it drew was bigger than 0.9. But if I keep doing it, there's a random number of times that it'll actually take before it stops. A similar kind of construct is called a while loop. While. A while loop takes a condition, like x is less than or equal to 0.9, and as long as that condition is true, it will evaluate the code chunk. So here the code chunk will be x is runif1, so generate a number, and then message the number. Notice here that I don't have to put in the break statement. That's because it's actually built in to the while itself. As long as the condition is true, it will keep evaluating it. So it'll run line 10 and then line 11. It will check, is x less than or equal to 0.9? If it is, it will run line 10 and 11 over and over and over again. So let's see this in action. I'll highlight it and run it. And this time, the x is still what it was before. So I'll initialize x to be 0. In general, any variables used in the predicate will need to be initialized before you can actually run the loop. So here, the predicate is definitely met before I start, and I can just run it. Okay, I would need to set x again to be 0 because, of course, at the end of the loop, x is 0.915. So I can run this over and over and over again, and it's identical to the previous repeat statement. Now, let's change the task a little bit. How would we message out the first 100 numbers? Think about that for a moment. Obviously, we don't want to do something like this. We don't want to say message 1 and then say message 2, 3, 4, 5, 6. Obviously this will work, but it's incredibly error prone. Even as I'm going through it, I'm tempted to type in the wrong number or to mistype the number or something like this. And if I want to type out the first 100, it's going to take me absolutely forever. A common way to do this is with a while loop. So I could say I'm going to initialize my iterator, I is 1, while I is less than or equal to 10, message I. But that's not enough, because if I don't do anything else to I, it will just message 0 forever because I itself is not changing. So I need to do something to change the iterator itself. I is I plus 1. Now, if I run this chunk of code, it will do exactly what I want. It will message the numbers from 0 to 10, and that works just fine. As it turns out, however, that's a somewhat uncommon use of a while loop. A while loop is more commonly used in a situation where you don't know how many times the code chunk should be evaluated before it should terminate. When you have a situation like this, a much more common looping construct is called a for loop. The for loop allows us to express this kind of loop in a very simple way by specifying the values that the index variable should take at the very beginning, and it does that as a vector. The syntax looks like this. For I in, now the vector, 0 to 10, message I. So this is the only line of code that is going to be evaluated, but it's going to be evaluated each time for each I in the vector 0 to 10. Let's see what it looks like. This is precisely the same statement as we saw previously. For loops are absolutely pervasive throughout computing, and R is no different. R has a number of functional ways that it can try to abstract away for loops, but for loops nevertheless constitute a major part of the language.